Hello students, we are looking at inverse function of mapping. Inverse function of mapping. Consider the function 2x plus 3 on the set A. So if this set A is the domain, into the set B, this is the codomain. So that is illustrated here. Now you realize that if you follow this mapping, this through, this will give us minus 2 will give us an image of minus 1, 1 will give us an image of 5, and 3 will give us an image of 9. Now the function, realize that if we decide to know this is the mapping of this set A into B is 2x plus 3. But in a situation whereby we want to reverse the operation, we want to make this A the domain, we want to make B the domain and A the codomain. So to reverse this operation, it means that you are going to use the inverse of f. So that means the mapping of f, for you to be able to get an operation that will reverse this, that is called what we know as well the inverse. So the inverse of f will give us what we now make this b the domain, while a will now become the codomain. For you to look for the inverse, that means you are going to look for a reverse operation that will make this element give us this as the image. So to make 9 to now give us 3, 5 to give us 1, and minus 1 to give us minus 2. So the operation that makes this be the domain, while this one the codomain, is known as the inverse. Now there are sometimes also that it is not all the time inverse of an element, inverse of a matrix is possible. Let's look at this. If this is a set X, in set X you have this, in set Y you have this. For you to look for the mapping, you are associating minus 1 to 1 here, 0 to 0, 1 to 1, and 3 to 9. So this is a mapping. But if you now look at the inverse, you realize that if you want to look at the inverse here, you realize that this one will have two different images here, and this shows that this one is not a mapping. So therefore you can say that we therefore conclude that not all functions have inverses. A function f has an inverse if it is both 1, 1 and onto mapping. So that is the only time you have an inverse. To make it easier, let me just read the whole lessons to you. Consider the function of this mapping on the set A, minus 2, 1 and 3, into the set B, minus 1, 5 and 9, illustrated below. So this is a diagram. The function f takes an element from the set A to produce a unique image in the set B. Suppose we consider the relation which reverses the operation of associating an element from the set A unique element in the set B. Let the relation be G. The relation G associates with every element in B is be a unique element in A. So if this is A, so this shows G happens to be the inverse of the operation of F. So the relation G is a mapping, and it is called the inverse of the function F, and it is usually denoted with F inverse. So to denote it, we are going to use F inverse. So F inverse will be replacing what? G. considering the relation, this particular relation to be the mapping of f to be what, x square on the set -1, 0, 1 and 3 into the set of 1, 0 and 9. If you consider these two inverse, so realize that this mapping f and this is g, so g is the inverse of the mapping of f. So it is obvious that the relation f is a function since every element of the domain has a unique image in the codomain. The inverse relation is illustrated above is not a function because the element 1 is a member of y has two images -1 and 1. So this 1 which is a member of y is having two images here. So this could disqualify this as mapping. So that means we therefore conclude that not all functions have inverses. A function f has an inverse if it is both one-on-one and onto mapping. Now let us consider this example. So to know how you are going to treat this, the function f over the set of real numbers is defined by f of x is equal to 1 over 2x minus 3. Find f inverse. You are told to find f. Now let us look at this example. The function f over the set of real numbers is defined by f of x is equal to 1 over 2x minus 3. Find f inverse. So you are told to look for f inverse. Now, if f of x is equal to 1 over 2x minus 3. Now, if, look at this, let the inverse of x be equal to 1. The inverse of f be equal to y rather. So that means you are going to equate this mapping to y. So that means you now say y will be equal to 1 over 2x minus 3. So what you now do here is to make x the subject of formula. You are going to make x the subject of formula. So that means this is minus 3 here. When you come see, when minus crosses the equality sign, turn to plus. So you'll be having y plus 3 is equal to 1 over 2x. So this 2 is dividing here. When you bring it here to come and multiply y plus 3, so we should give us y into bracket y plus 3 is equal to x. So it's this same thing as saying x is equal to 2 into bracket y plus 3. So you can realize that now we've been able to make x the subject of formula. So to now the inverse of x, the inverse of this function is now 2 into bracket y plus 3. So we are now going to express this 2 into bracket y plus 3 in terms of x. So where we are having y here, you are going to substitute with x. So that means in place of y, you now put 2 into bracket x plus 3. 2 into bracket x. So that means the inverse of 1 over 2x minus 3 is 2 into bracket x plus 3. Let's look at this other example. Let G define the mapping of G be x cubed plus 3. Be a function of a set of real numbers. Find the inverse of the function. So this is the mapping. So you are told to look for the inverse of this. So first of all, let the inverse of G be equal to y. So you want to make the inverse of G be equal to y. You can see how to show the inverse here. G inverse is equal to y. So what you are going to do is you now equate this G to y. So y will be equal to x cubed plus 3. So from here you make x the subject of formula. So that means this plus 3 here. When plus crosses equality sign, it will now turn to y minus 3 is equal to x cubed. Now to remove this cube, you now use this cube. When cube crosses equality sign, it will now turn to a cube root. So now turn to the cube root of whatever thing it means here, y minus 3. So this can be written as x is equal to cube root of y minus 3. Since you are having this, now you know that your y is, you said you are equating this to what? To y. Now you realize that the inverse of g inverse is same thing as what? 3 cube root of y minus 3. G inverse is same thing as cube root of y minus 3. So if you want to write the inverse in form of in place of x, wherever you see y, you are going to replace it with x. So the inverse of g is now a cube root of x minus 3. X minus 3. Now look at the work practice. So number 1, the function f is defined on a set of real numbers by f of x is equal to 4x plus 3. Find f inverse and n. Determine the images of the inverse when the inverse is minus 1, 1 over 2 and 0. Number 2, we having the function f and g on the set of real numbers are defined by the mapping of f is 3x minus 1 and that of g is 5x plus 2 respectively. Find, you are told to look for the composite mapping of each of these. Please ensure you like, subscribe and comment on this video. Thank you.